Hi, everyone. I'm Aaron Larson, executive editor of Power Magazine, and today I'm joined by our senior editors, Sonal Patel and Darrell Proctor, and we're going to be previewing the July issue of Power Magazine. July is our Plant of the Year issue every year. So, Sonal, why don't you go ahead and reveal the Plant of the Year to our audience for 2025?
This year we picked South Fork, which is a new wind farm in New York, and it was an honor to pick it. Every year we have a tough time picking the winners of the top plants, but the plant of the year is especially important because it exhibits all the distinctions that an industry winner should. So in 2025, the bar for excellence was really defined by resilience under pressure and precision across disciplines, and the rare ability to deliver complex infrastructure amid what we're looking at is really this heightened uncertainty. And this year, South Fork wind, it came at a really critical moment for offshore wind in the US. The industry is in a downturn, and since 2023, more than 12 gigawatts of projects have been canceled or delayed. And a federal executive order has paused new leasing. Costs have risen sharply because of inflation, supply chain breakdowns, and interest rates. And investor confidence has really dropped. And community and political opposition has intensified, especially around transmission. So in that context, South Fork Wind, it did something that just few thought was possible. It really delivered. The history of the project is really interesting. It was commissioned in July 2024, and it became the first commercial offshore wind farm in U.S. federal waters. And today it delivers 132 megawatts, including to 70,000 Long Island homes under a 20-year PPA, one of the first, with LIPA, which is the Long Island Power Authority. It achieved a 56% capacity factor in its first winter, which is comparable to some baseload facilities in that region. And it was built, really with novel approaches. It features 12, 11 megawatt Siemens Gamesa turbines on monopoles in waters of up to 43 meters deep. To get it connected, they had to build a 68-mile export cable, which was manufactured in South Carolina, with a lot of drilling and other operational approaches that were brand new to the U.S. So, I mean, when you look at this project, it just is an American first for all sorts of things. Even the way that they're going to operate this plant is fresh. They've commissioned a first U.S. flagged crude service vessel built in Louisiana. And a big part of the story that really stood up was its really complex supply chain, because they had to essentially put together this brand new chain, including for workforce. Then they stood up 2,000 jobs created across 19 states. Another thing, I'm going to have to keep talking because it is the plant of the year, but it is an especially, novel project for us, and which is the reason that it has won our highest honor. But it was permitted under the federal Fast 41 program, and it required a lot of coordination across federal agencies, state regulators, utilities, and community stakeholders, and a lot of environmental considerations. So I think because of the labor, because of the fresh approaches, the innovation, and all of these functioning components, we awarded the Plant of the Year.
Yeah, I really thought it was an amazing project, and the fact that it got done in the time that it did is really remarkable, and it really is a game changer for the U.S. market, which has struggled to get these offshore wind farms built and permitted and basically off the ground. So I think it's really important, and I think you did a great job covering the story. So other awards that we highlight in our July issue include the Reinvention Award, the Water Award, and the Hydrogen Award. Darrell, you worked on the article for the Reinvention Award. Can you talk a little bit about that project and what you found?
Sure, and thanks for that. The University of Washington had a 1960s era steam plant, and like many college campuses over the past few years, they've been looking at ways to improve the reliability of their power supply for the campus. A lot of times it's both heating and electricity, and in this case, at what University of Washington, affectionately known as UW, among those in the know. Stanley Consultants, known for its engineering expertise, created an extensive matrix to evaluate the feasibility of all the possible options for upgrading the power plant. And it was decided a diesel rotary uninterruptible power supply, or DRUPS system, manufactured by High-Tech, was the most economical and efficient option. So they looked at batteries, fuel cells, renewable energy, heat pumps, sewer waste heat recovery, electric boilers, combustion turbine microturbines, selected the DRUPS technology. It provided the plant with the necessary electrical reliability and lessened the university's reliance on fossil fuel technologies. Now, some people may say, well, it's still powered by diesel, which is true. But one thing that we're seeing right now in the industry is a lot of gensets, which traditionally have been powered by diesel and natural gas, and they're proving to be more economical and frankly, more reliable in a lot of instances. And that's really what the university was looking at. UW is thought to be one of only a few campus sites in the US to utilize the DRUPS system. It's essentially a 6-ton flywheel continuously spinning at more than 4,200 revolutions per minute, keeps the campus power plant operating when the electricity supply to the university is disrupted. So, it can just be a few milliseconds or just a blip of an outage, but the diesel engine will kick in, maintain the power supply, and really result in no interruption to electricity service. Because this was an upgrade of technology that literally was 60 years old, we thought it was very much a worthy recipient of the Reinvention Award.
All right. Thanks, Darrell. And concerning the Water Award, that was an article that I wrote. It was based on a project that Burbank Water and Power did in California. It was a groundbreaking stormwater capture and reuse system that they implemented and installed. And for people that are familiar with Southern California, they understand how important water is to that area and to that community. So this is really kind of a important project to basically improve plant reliability at the site. It gives an alternative source of cooling water for the facility. It's estimated to save about 18 million gallons of water annually. So it is a significant amount of water that's being able to be captured and reused. And it supports the Burbank Water and Power's Eco Campus sustainability initiative. So it was something that I think was really important to the community and certainly important to the Burbank Water and Power company. As far as the Hydrogen Award goes, Sonal, you also worked on that project. That was a Chinese project. Can you talk a little bit about it?
Sure. We picked CHN Energy's Rudong offshore integrated PV hydrogen storage project. This project was built on degraded tidal flats in Jiangsu province in China's first utility-scale facility to integrate offshore solar, battery storage, and green hydrogen on a single site. And then it delivers today 460 gigawatt hours per year from 400 megawatts of offshore photovoltaics supported by 60 megawatts of battery storage. And then a facility that produces 1,500 normal cubic meters per hour of hydrogen from the surplus power. And it's the interesting consideration of this project is that it was an ecological intervention. So essentially, the Rudong site is built on is basically tidal flats. I was overrun by Spartina anterniflora, which is an invasive species that was devastating native wetlands. So they installed elevated PV platforms engineered to allow tidal flows and marine activity. And it was a fantastic project that really, solved the problem and produced excess solar and, built a hydrogen facility that now it uses to distribute hydrogen for fuel cell vehicles, fishing vessels, and green ammonia production.
All right, thanks, Sonal. And beyond the awards articles that we are featuring in July, we've also got articles on hydropower, which was a focus. In one of them, the title is Flow State, the Connected Future of Hydropower Generation. That was contributed by Emerson and includes a lot of important information about automation in hydropower facilities. There's also a story on an air gap measurement tool that was submitted by Cammon. They have a static air gap tool that is a portable measurement device that helps reduce downtime by providing fast, repeatable, and reliable means of measuring one of the most critical aspects of the hydro generator, that's the air gap. Also, we have an article on power plant efficiency, how AI models are revolutionizing heat rate optimization. That was contributed by an outside source who's associated with McKinsey. Also, we have a NASA submission about how they're empowering energy projects by providing global Earth observation data. So that's an interesting article about where to and how to get projects developed in the right locations and in the right using this observation data that NASA provides. Also in this issue, I've got a mid-year industry forecast that's focused on renewable energy and how it's been surging. I wrote that article, and it talks about the electric power sector and some of the challenges that are being faced with integrating renewables as it continues to boom, continues to be the major source of new generation in the U.S. It also talks about data centers and how electrification is continuing to cause growth throughout the industry and how that growth can be met with new generation and some of the infrastructure that needs to be upgraded to help assist in that integration. In our Global Monitor section, Darrell, you had a couple of articles that you wrote. Can you talk a little bit about those?
Yes, thanks, Aaron. I'll start with talking about Chile. Country's really beginning to focus on solar power and energy storage to expand its generation capacity. Lots of projects going on there. I think in terms of that country, historically, it has a great potential for solar power. And then, a lot of battery energy storage companies moving in there. One of them, Miami, Florida headquartered Global Renewable Energy Group, Atlas Renewable Energy, inaugurated a battery energy storage project in partnership with Chile energy giant Copec and then EMOAC. That project has 200 megawatts of solar power and 800 megawatt hours of battery energy storage. I think, the article talks about a lot of different projects that are going on there. Will enable, a reader to learn more about what's happening in that particular part of the world. And then also wrote an article about Taiwan. Now, Taiwan, obviously, huge tech industry. And this sort of dovetails, as Aaron mentioned before, about data centers. So as the tech industry continues to grow, particularly the energy intensive semiconductor industry, which is really the center of Taiwan business, again, they, like many places at this point, needing to increase generation capacity to supply these companies. And one way that they're doing that is by increasing imports of liquefied natural gas. Taiwan imports LNG mostly from Australia, Qatar, and the US. There's 3 terminals right now that are operated by the state-owned China Petroleum Company. So they, at the moment, have about 22 gigawatts of gas-fired power capacity in Taiwan fueled by LNG. That's only going to grow. The LNG market, interesting, of course, because the U.S. in the past few years has ramped up its exports of LNG for a long time. It was a really contentious issue. depending on the whoever was in the White House. It would appear now that U.S. LNG exporters have more of a free rein to export, and Taiwan is certainly going to be one of those markets that they're going to be looking at.
All right, thanks, Darrell. Sonal, as part of the Global Monitor, you always produce a great big picture infographic, and it focused on the state of the global offshore wind industry. One of the things I particularly found interesting was how much China is doing with offshore wind.
So the infographic takes data from the Global Wind Energy Council's April released Global Wind Report. And what it really tries to show is how wind installations have grown unevenly. Last year, they reached 8 gigawatts, which is 5 times the global total from just a decade before. And China is really dominating development in key markets in Europe, and Asia are advancing just as quickly. There is a significant pipeline emerging in the US, just like I said, what we reported in depth in our Plant of the Year story. But the sector is really looking at some complex issues: rising capital costs, inflation impacts, supply chain issues, and these factors have triggered many cancellations and contract renegotiations, especially in the U.S. and European markets. So I think that what that means is there is a potential opening for big markets in China and elsewhere around the world.
Hey, one thing I will add here real quickly, though, for anyone, and all of us have written about this extensively, but some people say it's akin to an arms race in terms of ever larger offshore wind turbines, and China has been at the forefront of that, with many companies coming out with now 16, 18, 20, 22 megawatt wind turbines. The key here is how many of them actually will be deployed, because the larger the turbine, the more issues with safety that can come. Again, we've written about this extensively, but it's always interesting because China just seems to be moving forward in so many areas, but offshore wind is definitely one. Sonal's big picture in the Global Monitor takes a good look at that. And I would encourage everybody to really pour into the data there.
Thanks both of you for that and really interesting insight. One of the last things that I'll touch on today is my Speaking of Power column, in which I talked about district energy and combined heat and power and how those can be utilized to improve efficiency. I think it's a really important way that we can save energy and utilize valuable resources to heat and cool in cities and on campuses and other areas. So I'd ask readers to check that out also in this issue of the July issue of Power Magazine. And so with that, I guess thank you for watching, and thank you, Sonal and Darrell, for your insight on the July issue of Power.